Well, welcome to lecture, well, actually to module number 5. This module is throughout the week, we're going to be looking at two very important systems that are very interconnected, and that's water and agriculture. Our modern agricultural systems are obviously very dependent on water. So if we are running out of water, which we might be, does that mean we are also going to be running out of the ability to feed ourselves? That's sort of the issue that we are going to focus on this particular week. And here in lecture 5.1, we're just kind of getting our feet wet, per se, and providing some basic terminology and information about where we're currently sitting with in terms of water sources in the world. So by the end of this particular lecture, you should be able to explain sort of essential elements of the water cycle. I know that you've studied the water cycle before, so this is just a very, very quick review. But what we're really hopefully going to focus on a little bit more is for you to know and understand how we have currently globally mismatches between water use and water resources and how that can cause this concept of water stress. And then you should be able to use the term water stress appropriately. So there's 5 key terms coming out of this particular lecture that I want you to know, understand, and be able to use. Water stress, water scarcity, water rich versus water poor, and a water aquifer, and a water table. So like I do for all modules, when we're starting off a new module, I have 3 questions for you to reflect on, answer, and email me. What is one thing you already know about water resources? What is one question you have about water resources? And what is one experience you've had with water resources? So just pause, answer those, email them to me, and then pick back up with the lecture. Evaporates water from the oceans. So water gets sort of essentially pulled out of the oceans and into our atmosphere. Then gravity cycles that evaporated water back down into the oceans through precipitation. So water evaporates and then it falls to the earth as rain or snow or other forms of precipitation, and then it flows back into the ocean through our rivers, our streams, our groundwater, etc. There are over 100 million gallons of water that are evaporated into the Earth system every year. So that's an enormous amount of water that is flowing, being pulled up into the atmosphere and then being pulled back down into our ground and our rivers, our lakes, our streams, and our oceans. Most of that is returned to the oceans. Some of it does fall over land as rain or snow, and that's the amount that's available for humans to use. So if you were to look at Earth from space, you would probably be surprised that we are in a situation of water stress in much of the world. Most of the Earth is covered by water, but most of that water is in our oceans. And in fact, 96.5% of the world's water is in our oceans. And that means we are left with, and then there's other salt water that's in other areas like lakes that happen to be saltwater lakes, etc. So out of all the water that we have on Earth, 2.5% of it is actually fresh water and water that's available for use by humans. Salt water is not usable by humans unless it's very expensively treated because it's salty. And we're actually going to look at desalination in our case study this week. So if we look at our freshwater stocks, we have 2.5% of all the water in the world is freshwater. That's what's available for humans to use. However, more than half of that water is frozen in our glaciers and our ice caps, and it's also unusable in its current state. We're not going to go up to the glaciers and chip off a bunch of ice and melt it so that we have fresh water. So if we subtract that 68.7%, that leaves us with the remaining amount of water that we have available to us. 30% of that is underground in our groundwater system, and then just a little over 1% of all fresh water, which remember is only 2.5% of all water, is actually available through rivers, lakes, streams, and other surface water. So that is really the groundwater plus our surface water is really what we have available for us to use as humans for the things that we need. So let's talk a little bit about groundwater, because this is really the largest source that we have for water extraction and water use for humans. There is an enormous resource of water hidden beneath our feet, and that's in the form of groundwater and aquifers. So water is flowing under the ground through groundwater flow, and essentially it exists in the pores of and spaces between rocks. And so anywhere there is space where there isn't a rock, water can permeate from the surface down in through the ground and form our groundwater. And this exists consistently in many places around the world. In areas where there is quite a bit of space in the underground rocks, more water accumulates, and that water can flow a lot more easily. So those types of regions tend to hold a lot more water, and they're referred to as groundwater aquifers. So an aquifer is a type of groundwater, but not all groundwater is an aquifer, if that makes sense. Usually when we dig a well or put down a pipe to pump water up, we are going down into aquifers because this is the water that we can easily extract and pump up and use is aquifers. Groundwater that isn't an aquifer is harder to access, harder to extract, and less likely to be useful for humans. So it's the aquifer water that we tap into as humans. So when we do things like grow crops or capture water for energy production or industry use, it's usually into those aquifers that we're tapping. Groundwater in a lot of these aquifers and other sources underground oftentimes take thousands of years to accumulate. So really, when you think about it, it could take a millennium or more to replace the aquifer water as well. So if we're extracting water faster than the natural flow of water can replace it, we are in an unsustainable balance. We are drawing on our savings faster than we're replacing our savings, essentially. And when this happens, we are lowering the water table. So if we pump water out of an aquifer faster than which it is being replaced, we lower the water table. The water table is the line at which we have, it's the height or the depth at which underground rock is saturated with water. So if you dig down into the ground in your backyard or wherever, there's not a lot of groundwater in that part of the, in the first several feet or meters of underground. You have to dig deep, meters down. And as you extract water, the water table generally drops. That's what we're concerned about, is our water tables in our aquifers are dropping faster than what we are able to replenish water through the natural water cycle. So every time the water table drops, you have to dig deeper wells, and eventually, of course, you could actually use up an entire aquifer. So between these two maps of US groundwater aquifers, which are going to provide the bulk of the water, fresh waters for people living in the United States. Globally, this is where we're at in terms of um, groundwater that is available. Darker the blue, the more groundwater, fresh water, I should say, that is available. The lighter the blue, the less fresh water that is available. And you can see, like, for example, in Northern Africa, it's a very light blue. We know this is a very desert region, and so there isn't going to be a lot of surface water or groundwater. Now, um, in north, the northernmost part of North America, it's also a light blue. Um, Although there is a lot of fresh water in this region of the world, the reason why it's light blue is because that water is frozen. It's snow, it's glaciers, it's ice caps. It's not available for human use. The other thing I want to point out is that high population regions of the world are not necessarily also regions that have high precipitation. So we often will settle in places that a lot of people live there, and there isn't a lot of freshwater resources in that region. So those places are generally referred to being as water poor. They do not have enough water to meet the needs of the people that live in those regions. Regions that have a lot of water, they have large flows of water, and or low populations, are referred to being as water rich. They have significant stocks of water, probably primarily groundwater, um, and places that are water rich are obviously not under water stress. Places that are water poor generally are in a state of water stress. And in those places, it can be very tempting to start to dip into their savings. So to dig deeper wells and to draw on more and more of their groundwater. And as a result, many of the places that are in the lighter blue regions are drawing from their groundwater stocks and are lowering their water tables. So in the United States, you really can see the lightest blue regions is in the Southwest. This is a place that's known for withdrawal of water from stocks and lowering the groundwater table. So, for example, in Phoenix, the water table has dropped at least 400 feet, which is significant, since it became a modernized city. This is obviously a completely unsustainable use of water resources. Water is being extracted much faster than it can be recharged through the water cycle. And it turns out that a number of countries are sort of in a similar situation. Countries like India and China, they have large populations, they have a lot of agricultural industry. And as we'll see this week, egg is a huge user of water. And so the combination of population and agriculture is leading to very unsustainable extraction of water. And this can happen really easily if we don't have water priced properly, if we don't have it regulated, and if we don't have standards and mandates in place by our governments. So we've talked about what it means to be water poor, water rich. These terms relate to these other two terms, which is water stress and water scarcity. Um, Water stress means that it's becoming more difficult to obtain fresh water because of depleting resources. So the water table is dropping, it is getting harder to get fresh water to meet human needs. Water scarcity is actually a step more extreme than that. And basically, when you are in a region of water scarcity, you do not have sufficient water to meet demands. So you are either having to pump water in from other places, you're having to truck in drinking water, etc. And so many places around the world are actually already under water stress. There are also places in the world that are living in water scarcity. You can see with this global map, you can find Kansas in there, and we're actually already fairly heavily exploiting our freshwater systems here in the Midwest through our agricultural practices. Experts predict that regions that are classified as being under stress will increase in coming decades. With the leading cause being that we are continuing to increase our global population. the more people you have on your planet, the more people you have to feed, the more food you have to grow, the more water that you have to extract. So it gets back to what we were talking about several modules ago related to population, full circle here. So how are we actually using all this water? Well, we've already talked a little bit about this. It turns out worldwide, the single major user of water is agriculture. We often don't necessarily focus on agriculture. We often think about how we use water in our home, how we use it to generate electricity, how we use it to make things. But it turns out how we use water when we feed and grow our crops is the single most important thing. And so you can see here by year how much water we are increasing globally, and then it goes up to 2025, and you can see how much more we are using agriculture for agricultural practices versus domestic versus industry. Of course, this is not the case for all countries in that the fact that agriculture is the number one user of water. Interestingly, in the United States, the biggest user of water is actually electricity generation. But so when we generate electricity, we have to use a lot of water to cool things down. We have cooling towers so that our electricity generation plants don't overheat and combust. So we have cooling towers. Well, the water that's used in that water, those cooling towers, it's large volumes of water, but it remains fresh water. So it eventually is returned back to the water cycle. So you can see that in the United States, agriculture is not the dominant use of water. Industry and agriculture sort of are shared in their amount that they use. In places like Canada and Russia, it's actually industry. But in countries that don't naturally get a lot of rainfall and precipitation, like Africa, Australia, they are using most of their water resources to water their crops. And so that, as a result, on average, worldwide, agriculture is the number one user of water. Most of the increase in water use that we are seeing in the world today is occurring in countries that have increasing populations. Many of the industrialized countries, like the United States, have become actually much more efficient in how we use water over the last couple decades. And so in places like the United States, Europe, Canada, we're actually sort of seeing water use flat. So even though we're seeing slight changes in population in the United States, because we've become more efficient in how we use water, we aren't using more water, if that makes any sense. So that's sort of the basics of what it means to have water scarcity, water stress, why we have water scarcity and water stress. And in the future lectures this week, we will look into that more.